you doing?
I'm breaking rocks.
No!
I wonder where that mad titan is, trying to destroy the known calculator.
Then it was none of your area between curves, Stone, Captain America.
My area between Curbstone, Thanos, you'll have to go through me to get it.
We'll see about that.
Not my area between curves.
So your first step is to look at the two functions and figure out where they intersect on the graph. So in this case, your intersection points are going to be -2, 0, and 2. And you can see that the function is symmetrical from -2 to 0 and from 0 to 2. So you want to make your integral from -2 to 0 of the function and then add the integral from 0 to 2 of the function. And because it is symmetrical, you can combine these together to make it 2 times the integral from -2 to 0 of the function. And then you can evaluate that on a calculator or by hand in order to get the answer of 128/15.
The area between Curbstone is mine. I'm here for your stone, Groot.
I'm Groot.
I'm gonna take it.
I'm Groot. I'm Groot. I'm Groot.
What are those?
I'm Groot.
Keep my mom out of this.
The total distance and displacement stone is mine. The first step of this problem is to understand that the acceleration is equal to the derivative of the velocity. So once you set your equation equal to dv dt, you must then variable separate so that you are integrating with respect to time. Once you integrate your equation with respect to time, you will have a plus c because you used an indefinite integral. So now you must solve for that c in order to complete your equation. However, you don't need to do anything because you know that your initial velocity is 0. And when you plug in zeros, you get that c is equal to 0. So now that you have your velocity, you can simply plug in v of 9 and get that your velocity after 9 seconds is 63 feet per second. Part B of this problem entails finding the distance traveled by the car from time 0 to time 9. In order to achieve this, you simply have to integrate your velocity equation from 0 to 9, and then convert miles per hour to feet per second. Once you do this, you will get your answer of 344.52 feet.
I've been here for thousands of years. I know what you seek, Thanos.
Do you?
Yes, but there is a price you must pay.
And what is that?
You must give up the only thing you love.
No. I've been searching for this for so long. I'm sorry.
What you say? Oh, that you only meant well.
The first step of this problem is to solve your equation with respect to x, because you are rotating your solid around the x-axis. The next step is to plug your equation into the volume formula, which is volume equals pi times the integral from a to b of f of x dx. Your a and b values are 0 and 2, because that is where you are integrating from. Next, you must plug in your equation into the formula, and then solve for the volume. Once you solve for the volume, you will get a value of 2 pi over 3 units cubed.
Oh, God. Where am I?
You're back at your house. We called you an Uber. You were super drunk.
Oh, sick. Oh, and I have the solid revolution stone. Yay!
Thanos, I've come to bargain.
You can bargain with my fist, strange. The shell method stone. It's all mine.
If you wanted to revolve your object on the y-axis, you'd have to use the cylindrical shell method, because you want to keep your equations with respect to x. So, you must use the formula, the integral from a to b of 2 pi r h, where your r is x, and your h is x minus 1/4 x squared. When you plug all of this in, along with your limits of integration from 0 to 4, you will get an answer of 32 pi over 3 units cubed.
The washer method. The last stone I need to erase all of calculus.
I'm calculus's last defense.
Finally, the last stone.
Ow!
For this problem, you must use the washer method, because your equations are with respect to x and you are rotating around the x-axis. In order to solve this equation, you must use the volume formula for the washer method. This formula is the integral from a to b of pi times r2 squared minus r1 squared. In this equation, your value for a is 0, your value for b is 4, your value for r2 is x, your value for r1 is 1/4 x squared. Then, once you evaluate this, you get a final answer of 128 pi over 15.
All of calculus. Mine! With all the stones, I can destroy all calculus throughout the calculators with one snap of my fingers. And it's about time.
Mr. Stark, I don't feel so good.
I wonder where that mad titan is who's trying to destroy the calcuverse. I wonder where that mad titan is who's trying to destroy the known calcuverse. It is I, Thanos, here for your area between Curvestone. My area between Curvestone? You'll have to go through me to get it. I can't. Okay. I wonder where that mad titan is who's trying to destroy the known calcuverse. It's me, Thanos, and I'm here for your... I've been trapped here for thousands of years. I know what you seek, Thanos. You just woke me up from my nap.
Seriously, she's freaking out.